ATEN by Volt Power Group is a breakthrough technology comprising proven subsystems delivering incremental zero-emission electricity through the capture of gas turbine exhaust waste heat. Energy that would otherwise be vented directly to atmosphere. This technology offers a AAA solution. It's affordable, it's available now for rapid deployment, and it's zero-emission acceptable. Open-cycle gas turbine power stations are a common feature across Australia, offering fast response power supply with half the emissions of coal. ATEN enhances this generation capacity by an incremental 20 to 30% with no additional fuel gas consumption or emissions, offering an immediate carbon reduction impact. Not only does ATEN contribute to low-cost decarbonisation, but it also bolsters baseload capacity, network stability and energy security in high-penetration renewables networks. In addition, ATEN requires a small site footprint, usually within existing power station site boundaries, minimal regulatory approvals, has no water or operational personnel requirements, and can utilise existing network connection infrastructure. A rapid project delivery schedule timeframe includes a short 6 to 9 month on-site construction period. The ATEN waste heat recovery unit captures thermal energy from turbine exhaust and transfers it to a thermal oil carrier. The hot thermal oil circulates in a continuous loop, moving thermal energy from the gas turbine exhaust to the Organic Rankine Cycle (ORC) subsystem. The hot thermal oil is exchanged to the ORC working fluid, and the cooler thermal oil is then pumped back to the waste heat recovery unit to repeat the heat recovery cycle. The recovered thermal energy transforms the pressurized ORC liquid into a hot pressurized vapor. This high-pressure, high-temperature vapor undergoes isentropic expansion across the expander turbine to create mechanical rotation, turning a generator and producing a zero-emission electricity supply. The vapor exits the expander turbine at a lower temperature and low pressure. This low-pressure vapor is then cooled and condensed back into liquid form in an air-cooled condenser. Finally, this ORC liquid is pumped back to high pressure and returned to the ORC to repeat the cycle. Volt Power recently completed a comprehensive study that confirms ATEN's potential to deliver significant carbon emission reductions when retrofitted to an existing 80 megawatt power plant incorporating 2 open-cycle gas turbines. The completed study confirmed that ATEN would deliver 20% or 15 megawatts of additional baseload generation capacity, a 20% reduction in power station carbon intensity emissions, an additional 115,000 megawatt hours of zero-emission dispatchable electricity supply per annum, and achieve this enhanced efficiency performance across the 50 to 100% turbine operational duty range. The study also highlighted the significant potential affordability benefits of ATEN, confirming a levelised cost of electricity, LCOE, of $55 per megawatt hour and marginal generation cost of $20 per megawatt hour. These cost results are significantly lower than the equivalent renewables and gas generation costs. Volt Power and the NRW Primero Group have joined forces in a strategic alliance to deliver ATEN across the energy and resource sectors. By combining Volt's ATEN technology with NRW Primero Group's EPC expertise, the alliance offers turnkey solutions that reflect our dedication to an accelerated high-efficiency, affordable energy transition. Discover how ATEN can accelerate your path to decarbonisation by visiting voltpower.com.au/ATEN.